Okay. Hi, kids. How are you doing? Good morning, good night, good afternoon. I hope that you are having a good time, that you're having a good summer. So, I'm going to share something with you. Yesterday, I recorded lesson one and lesson two. To then notice that lesson two was not properly recorded. So, that was a sad thing. Uh, so, I'm gonna record lesson two again, but to do that, I need to reprint this because lesson two involves like constructions, and you need to have a compass, and you need to have like a ruler. So I'm gonna make lesson two again in after doing lesson three, lesson four, and lesson five. That I don't need to do anything special. So I prefer to do lesson three first. I will be uploading lesson two later. Okay, so let us begin with lesson three. Lesson three is a really cool lesson because, like, it is the first approach to studying shapes through algebra. So that is what we're going to be doing. Okay, an easy starter. Pause this. It should take you like at least 2 minutes, tops 3 minutes. It is really easy because you need to remember that when you have this type of angles, these are called vertical angles. And why are they called vertical? Because this thing is called a vertex. So vertically opposite angles, this measures 36. Now, this is a line. The whole line has an amount of 180 degrees. So if this is 121, this is easily 180 minus 121. O sea, that is 59 degrees. And for this one, remember that around a point in a circle, around a point, we can find 360 degrees. So C is just 360 minus 82 minus 172. I don't have my calculator with me. Okay, but you do it. Maybe I need to bring my calculator. Let me open a calculator here. Calc. Okay, that is 360 minus 82 minus 172. And that is 106. So C is 106. Okay. So the total measurement of adjacent angles around a point is 360. Now, two angles are complementary if they add to 100. Sorry, they are complementary if they add to 90 degrees. So two angles are complementary if they do something like this. So this angle plus this angle, they add up to 90. And they are supplementary if they add to 180 degrees. This one, we also call them linear angles. You have a line, and this plus this add up to 180. So these ones are supplementary. Okay, so now we will be solving some exercises about this. I believe that you can solve them by yourselves, but I will be solving them with you. Of course, you can skip or like make the video go faster, or you can skip it. I don't know. So for example, this one's very easy. This is just 144 minus, this is 180 minus 144. And that's an easy 36. Okay, for this one is also easy. You do 180 minus 97 minus 36, and that is 47. Okay, so here now we know that because this is 90 degrees, we know that these angles are complementary. So I could do 180 minus 90 minus 40 minus 36, but instead I'm just going to do 90 because I know that this add up to 90 minus 40 minus 36. And 90 minus 40 minus 36 is a 36. Okay, now because we have the same letter twice, we know that in this case, D plus 82 equals to 180. So here we just need to solve this equation. So we collect like terms. To D, we subtract 82 equals to 98. So D equals to 98 divided by 2, and that is 98 divided by 2, that is 49. Okay, so now we have angles around the point. Okay, and now we have that. I'm going to write it in a fancy way. 3 times 91 plus 3 times G equals to 360. Do you agree? Okay, so 3 times 91 is 273 plus 3G equals to 360. Now I do 360 minus 273 and I get 87. So 3G is equal to 87. And now I divide it by 3 and I get 29. G is 29. Nice, nice, nice. Okay, so here it gets a little bit more complicated. I am in problem 6. So you need to write an equation again and set it equal to 360 because you're dealing with angles around a point. So you do 2x plus 85 plus x plus 35 equals to 360. So you have that 3x plus 85 plus 35 is 120 equal to 360. So we subtract 120 in both sides. So we have that 360 equals to 240. So we have that x is equal to 240 divided by 3, and that is 80. Nice. Okay. Now, this one, you may want to set a system of equations, but you don't need to. Even though that you have two variables, because there is a nice trick in here. Observe that y plus x and y minus x are linear angles. They are supplementary. So y plus x plus y minus x, that is equal to 180. And that is a trick. Because what happened to the x's? They cancel. And I collect like terms and I get 2y equals to 180. Y equals to 90, no? These x's are canceled. Then you can plug it in. Then now you know, for example, that 2x is the same as y minus x. So 2x is the same as y minus x. So 2x is the same as 90 minus x. So adding x in both sides, we have that 3x equals to 90. So x equals to 30. So even though that adding all the angles and setting it equal to 360 is a strategy, it is not always the solution. If you tried to do this in here, so for example, you could have said, oh, this is also y plus x. But if you do y plus x plus 2x plus y plus x plus y minus x, the x do not get canceled. So you actually need more information in the problem. Setting just one, and that makes sense. One equation for two variables, that won't give you the answer. Okay, now, so for example, here, this is very interesting because this angle is the same as this angle because they are vertically opposite. Do you see it? Like here you have a line, here you have a line, and this angle is opposite to this angle. So this is 4x minus 10. And now, because this is a 90-degree angle, we know that this is a 90-degree angle. And so 4x minus 10 plus x equals to 90. So we have that 5x minus 10 equals to 90 by collecting like terms. So we have that 5x equals to 100. So x equals to 100 divided by 5, and that is 20. So now I can imagine that you're tempted, again, you're tempted to do a system of equations that can be very complicated. So first, analyze the problem. There are some nice relations that you can get from here. Okay, so why don't we try to complete the diagram first? So for example, I know that this angle is the same as this angle. So this is x minus 11. And now observe that this angle, x minus 10, x minus 11, and 3x plus 6, they are collinear. So these three add up to 180. And that will be an equation that only has x as a variable. So here I can write the equation x minus 10 plus x minus 11 plus 3x plus 6 equals to 180. And that will give you 5x minus 10 minus 11 minus 21 plus 6 minus 15 equals to 180. And then 5x equals to 180 plus 15, that is 195. And 195 divided by 5, I strongly believe that that is 19. Let me check. No, it is 39, sorry. Okay, and now that you know that x is 39, observe that y is the same as 3x plus 6. So y is 3 times 39 plus 6. So that is 123. Okay, and now this one, you may think that it is hard, but just because it has fractions. So the problem in here would be dealing with the fractions. I know that I need to show you something. Fractions are friends. So if you look at the three angles, so this angle is the same as this angle. Did you agree? Because they are vertically opposite. So here I have 3/4 of x minus 2. And now you can add this plus this, and that will give you 90. Why 90? Because here you have a 90 angle degree, and here you have a 90 angle degree. So those two angles are complementary. So you have the following equation: 3/4 of x minus 2 plus 2/5 of x equals to 90. So you need to collect like terms. So you need to add 3/4 plus 2/5. 3/4 plus 2/5. So remember that to add fractions, you need to have the same denominator. So in each fraction, I need to multiply it by something. So the greatest common is, sorry, the least common multiple of 4 and 5 is 20. So I'm going to multiply this fraction by 5, and I'm going to multiply this fraction by 4, so that the denominators are 20, or the denominator is 20. 15 20s plus 8 20s. So that will give you 23 20s. Because when you add fractions, the denominator stays the same. So by collecting like terms, this equation turns into 23 20s of x minus 2 equals to 90. Okay, now I add 2. 23 over 20, x equals to 92. Now, fractions are friends. How do you wanna solve this? Okay, so in a strategy, you can say, well, I divide 92 by 23 20s. But kids, I believe that's easier if you multiply everything by 20, so you erase that denominator. So it would be 23x equals to 92 times 20. 92 times 20, and that is 1840. And then divide that by 23. So x is 80. Okay, I hope that it is clear. Now, for this lesson, we need to understand angles in 4 contexts. The first context is around the point. The next context is in transversal lines. Then we will see it inside of a triangle. And lastly, we will see it in polygons. So up to here, all the exercises were about angles around a point. Now we will do it in transversal lines. Okay, so you have seen this drawing before. This mark, this particular tick, means that these lines are parallel. So whenever you see, for example, something like this, this means that the lines are parallel, but they are not necessarily congruent, no? So this is like a particular way of saying that these 2 lines are parallel and these 2 lines are parallel, but in between each other, this is not parallel to this, no? Okay, so we have some names for this angle, for these angles. So if you have your line, this is called a transversal that cuts your 2 parallels. So this angle and this angle, they are the same. A and E are the same, and they are corresponding. So A and E are corresponding, and they are the same. Also, B and F are corresponding. So they are in the same side of the line. So here I have my transversal. They are in the same side, and one is up and one is down. And well, yeah, one is interior and one is exterior. But be careful, A and B are not the same. A and E are the same, and B and F are the same. So these ones are called corresponding. So and you have more corresponding angles, no? So for example, a couple of pairs of corresponding angles are A and A and E, B and F, and they measure the same. Okay, so my favorite type of angles when dealing with this situation, sorry that I erased, but I need more, I need to use this again, are the alternate interior angles. So alternate interior angles are the C angles because you need to look for a C. So this angle, angle C and angle F, are alternate interior angles. Alternate because they are in different sides of the transversal. Interior because both of them are inside of the parallels. So C and F are alternate interior angles, and they are congruent. Let me write it down. So C and F. Okay, but I have another C, no? I have another C. I also have this C. So D and E are also alternate interior angles. So corresponding angles are congruent, alternate interior angles are congruent, and we have same side interior angles that are supplementary. Okay, and these ones we will use them. So be careful. So same side interior angles. It's like I want to do this. No, it is like a staple. Um, the staple angles. These ones are supplementary, so that means that DNF add up to 180. And we will use them. Believe me that we will use them. So remember them. DNF add to 180. And also, oh, these ones I can draw in the other side. C and E are also same side interior. Okay, so something that you need to know, because this will come in your test and this will appear in your life many times, whenever you have a problem, something like this, and you have like this angle, and you have like this angle, and you want this angle, something like this, you will always need an auxiliary line. An auxiliary line, it's a line, no, let me draw it with normal, how? An auxiliary line, it's a line that it's also parallel and that you can draw. So you can always draw auxiliary lines that are parallel. So in this case, if this is parallel, this is parallel, this is parallel, so you can always draw them. So that is like a tip. So if you see a vertex and you see a couple of parallel lines, then draw an auxiliary line through this vertex that is parallel to the other two. And you can always extend the lines. You can always extend the lines that they are giving you. And that will be useful. We will see an example of that. So for example, in here, they are giving you that drawing. So here is a parallel, and they are giving you this vertex. So this is called an auxiliary line. In this figure, we can use the auxiliary line to find the measurement of angle E and angle F. How? Okay, so in this one, you know that angle E is a what to angle 41? If you see, here you have a C. So angle E measures 41. And now, if you look here, you have another C. So this 35 is here. So what is the measurement of this angle, of angle W? The measurement of angle W is 41 plus 35, and that is 76. That is how you use auxiliary lines, because you can find alternate interior angles. And all type of angles, you know? Okay, again, so these problems, like during class, I gave them to my students and they worked on them. I'm gonna solve them, no, if you have any questions, but of course you can skip it, you can make it like faster. And I'm gonna do it fast, no? So because I know that you can pause them and everything, no? Okay, so angle C. Angle C, very quickly, well, we can start with angle A. Angle A is 53 because that is a corresponding angle. 53 and A, those two angles are corresponding, so that is 53. Angle B is vertically opposite to angle A, so it is also 53. And now angle C is not going to measure the same. Angle C is going to measure 180 minus 53, and that is 127. Am I right? I believe so. Okay, then here you have two parallels, and you have a transversal. And so this is an alternate interior angle, so this measures 35. And then D and 35 are collinear, so D measures 180 minus 35. And I strongly believe that that is 125. Okay, now you have a couple of parallel lines. And you know that, for example, if this is 54, the corresponding angle is this one. So this one measures 54. So E measures 54. And now a totally independent problem is finding F. So F, you know that here you have 112. So here the corresponding angle is 112. And now this one is going to be the complement, the supplement of 112. So that is 180 minus 112. And you don't need to involve anything around the 54 or the E. 180 minus 112, 68. Okay, now these ones are the type of problems that involve auxiliary lines, no? So here I have a parallel, and here I have a parallel. So my auxiliary line is going to pass through this vertex, and it's going to be also parallel to this too. So I'm going to draw it. Excellent. No, you know something? I'm going to draw it in black. Excellent. Okay, so now you can see that here you have an alternate interior. Oh my God, so pretty. An alternate interior angle of 56. And, well, if you extend this line, observe that here you have a parallel line, a couple of parallel lines, and a transversal. So if you want to, well, if you want to do it with the C's, well, I would do it with the, how are they called? Same side interior angles, no? I know that this one and 144 are same side interior. So this one is just 180 minus 144 because they are same side interior. So that is what? 36. So this measures 36. And now angle G measures 56 plus 36. And 56 plus 36 is just an easy 92. Okay, now, so we use the same side interior. Okay, now again, we have like a vertex situation and a two parallel situation. So I need to draw a parallel line that passes through that vertex. So I'm gonna do it. I'm gonna do it. No, no, no. I think that I can move it after drawing it. Beautiful. Beautiful. Okay. So again, this angle here, if you look, you have two parallels. So this is parallel to this. This is parallel to this. And this is a transversal. So this one is again a same side interior angles, no? So this one are same side interior. So you do 180 minus 98 equals to 180 minus 90, 90 minus 8, 82. So this one measures 82. And the same thing in here. So you have a parallel, you have a parallel, you have a parallel, and this angle are again a same side interior. So you do 180 minus 162, and that is 2018. So this measures 18. And now angle H is just 18 plus 82, and that is 100? I think so. I think so. Nice. Okay, this is just going to get harder and harder. Again, I'm going to draw a parallel. And okay, now this is 126, 117, sorry. And this is 117. Do you agree? Because they are corresponding angles. So if this is 117, this is 117 because they are corresponding angles. And now this one, then this one is 180 minus 117 because they are linear angles. And 180 minus 117, I know that you're not here to watch me doing mental maths, but it's pretty, no? Mental maths are pretty. Okay, and then you also know that this angle, the 129, is the same as this angle because they are corresponding. So finding this angle is just doing 180 minus 129, and that is 51. It is 51. So I is just 63 plus 51. 114. Okay, maybe you are tempted to use that formula that talks about interior angles in a triangle, but don't. Eh, so you know that here you have alternate interior angle. So you know that this one measures 46. Because alternate interior angles. What was the way? What was the way? What was the way? Then you know that you have another set of alternate interior angles. So this is 92. J is 92. Look, I am not using the formula for angles inside of a triangle. This is 92 because, and so this one are just because of alternate interior angles. And now K, this one, you can get it by adding the angles around the line, no? Because 92, K, and 46 are linear angles. So K is 180 minus 92 minus 46. I bless you. Thank you. So K is 42. And now this is a great exercise to introduce ourselves to the next topic, the topic of triangles. But I think that we have we still have three more. Okay, remember this one. This one was super cool. Okay, so we have a C. Wait, I would draw here auxiliary line. Oh my God, why am I doing it so badly? Okay, I would draw an auxiliary line and I would start using my alternate interior angles, no? So, okay, so this one is a 44. So this one is 44. So this one is 44. So if this is 44, this is 44. Do you agree? Because of a C that you have here. And then again, by a C, this one is a 37. So this angle measures 37 plus 44. That is 81. So this angle measures 81. Nice. Okay, this is a cool problem. So you have that this line is parallel to this line, and you have that this line is parallel to this line. So, angle, okay, so this angle, 68, is corresponding to this angle. Do you see it? Because, okay, let me see if I can extend the lines to make it more clear. So if I'm gonna extend the lines, and you have like this. So look at only at these lines and the ones that are like more thick. So if you look at this 68, this is a 68, no? Because they are corresponding. So this 68 and this 68. Now, if you look at, okay, now immediately you can find P, because P is going to be the angle, the linear angle for 98 and 68, 94 and 68. So this is 180 minus 94 minus 68. 194 minus 68. And that is 18. Okay, now look at the other two. Okay, I'm going to erase it. No, do I erase it? No, I'm not going to erase it. I'm going to use another color, orange. Now look at these two lines and this transversal. Now look at the thick orange lines. So if you look at the thick orange lines, you can see that this and this are corresponding. So this is actually 94. So P is 18 and Q is 94. Very good. Okay, so in this one, again, you have a vertex that is shouting. It is shouting something. What is it shouting? It is shouting, draw an auxiliary line. Okay, so I am hearing you. I'm also going to extend this line because I want it like longer. So, you know, this one is a super cool problem. Super cool problem. So observe that here you have a C of alternate interior angles. That means that this angle is R. But wait, that doesn't mean that R is not 96. No, no, no. R is just like a part of that 96, because the 96 is this whole angle. Does that make sense? And the R is just like that first little part. But it's okay. It's okay. Everything's okay. Because if you look at this C also, if you look at this C, you know how much does this angle measures? No, you know that this angle measures 60, because 60 plus 130, it's 180. So you know that this one, that this part measures, that this part measures 60. So what you are getting is that the whole line, 96, the whole angle, sorry, equals to 60 plus R. And now you can get that, well, you subtract 60 in both sides, so you get 36 equals to R. And that is the measurement of R. Isn't this a super cool problem? I believe that it is a super cool problem. Okay, angles inside of a triangle. We're going to write a proof. I'm going to prove you something. So you all know that the angles inside of a triangle add up to 180. No, you know that if you have like these three angles, A, B, C, A plus B plus C equals to 180. Okay, but the reason is why. And now this is a theorem. O sea, this is something that has a proof. It is not like a postulate. It is not like an undeniable truth and self-evident truth. This is something that you can actually argue. And now, how can you argue it? Okay, so the argument goes like this. Draw any triangle. And now, from this vertex, as we have been doing, from this vertex, create a parallel line to the opposite side. Ha. So this is something that we have been doing. No, you can always create a parallel line. So this is parallel to this side. And I'm also going to extend this, the opposite side. So you can construct a parallel line to the opposite side and extend the sides of the opposite side. Now look, this angle is an alternate interior angle, no? No, sorry. Whoopsie. Am I doing it? I am sorry. I would like to pause when I have a doubt so that you don't have to see me like struggling, but it's okay. It's okay. Okay, so this angle and this angle, no, Mr. Cachoa. Aha, this angle and this angle are congruent. Sorry. This angle and this angle are congruent because they are alternate interior. Also, this angle and this angle are congruent because they are alternate interior. And this angle is congruent to itself. So observe that each angle, A, B, C, are linear angles. So A plus B plus C add up to 180. And here's like the argument on why this is true. So the measure, and here's like that proof. So angle A, angle C, and angle B stays the same. So I didn't need to extend the sides of this triangle, that side of the triangle. So the sum of the three angles measured in the triangle is 180. A point that lies interior of the triangle, if it lies in the interior of each angle, okay. Any triangle, in any triangle, the measure of exterior angles is equal to the sum of the measures of the, okay, so for that one, observe this, observe the following. So if you have a triangle, and you extend this side, I'm gonna call this angle I'm gonna call this angle, this is an exterior angle. And you already should know from previous grades that the exterior angle is the sum of these two interior angles. And that kind of makes sense, no? Because, like, for example, you know that if I call this A and I call this B, well, you know that C is 180 minus A minus B. And also, what is this angle? This angle, the exterior angle, is 180 minus C. And what is 180 minus C? 180 minus 180 minus A minus C. So that is 180 minus 180 plus A plus C, because remember that when you have a negative outside of a parenthesis, you need to distribute it. So that makes a negative 180, a positive 1, a positive A, and a positive C. And when you collect like terms, that is A plus C. So this exterior angle is just A plus C. And that is what is saying in this line. In any triangle, the measure of the exterior angle is equal to the sum of the measures of the interior angles. And I don't remember this one. Please, I'm sorry. I'm sorry. Okay, base angles of an isosceles triangle are congruent. Each angle of an equilateral triangle measures 60 degrees. Okay, let us go for this. Now, you have that, okay, you want to find A. So finding A is really easy, no? Finding A is just doing 180 minus 69 minus 58. And I believe that that is 53. So that is A. And then B. How do you find B? So you know that this angle measures, what is the measurement of this angle? That one is just 180 minus 93 minus 58. No, this one measures 29. 180 minus 93 minus 58. But Mr. Cachoa, where are you getting that angle? Well, I am getting that angle because if you look at this triangle, you know that this angle measures, what is the measurement of that angle? That is 29 plus 58. That is 87. So you have a triangle that has angles 53, 87, and B. So B is just 180 minus 87 minus 53. It's 40. Good. Good, good, good. Okay. Now, this one is easier, no? So first, you get that angle, that is 180 minus 78, that is 102. And now, what is the measurement of angle? Okay, that is one strategy. But you already know that 78 equals to 42 plus A, no? Because this is an exterior angle, and these two are the interior angles. So you just need to do 78 minus 42, and that will give you 36. No, easier than doing the other angle. Okay, so now this is an isosceles triangle. In an isosceles triangle, you know that this angle measure, the base angle measure the same. So that is 68 and 68. So you can find this angle. But I think that you don't need to, because again, this is an exterior angle. And these two are interior angles. So B is just 68 plus 68. That is 136. Nice, nice, nice. Okay, now in this one, you need to notice first that angle. Okay, this is very easy, no? Because you have a big triangle. And so from this big triangle, you can get that C is just like 180 minus 90 minus 64. So C and 64 are complementary. That is, what is it? 26? Is it 26? 90 minus 64, 26. Okay, and then to get the, you need to look at this small triangle. So first, get this angle, that is 180 minus 95, that is 85. And now D is 180 minus 85 minus 64. 180 minus 65 minus 85 minus 64. That is 31. Very good. Okay, now for this one, so this one is a very interesting one. So first of all, what is the measurement of this angle? That is 180 minus 115. And that is 65. So this also measures 65. Um, and with this, I can get the measurement of this angle, no? So this angle measures 180 minus 30 minus 65. And 180 minus 30 is 150. 150 minus 65 is 85. Excellentus. Now I can get them. And now I've been doing things without like getting the answer that I want. Now I can get this angle, and this angle is 180 minus 85. That is, what is 180 minus? It's 95. So this angle measures 95. And of course, now I can start solving my problem. Because if you look at this triangle has angles 34, E, and 95. So if this measures 95, now I can know that this angle E is 180 minus 95 minus 34. 180 minus 95 minus 34. That is 51. Isn't it cool? I believe that these problems are like jigsaws, and I love it. I just love it. Okay, woof, woof, woof. In this one, we have a couple of parallel lines. So what are we gonna do? What are we gonna do? What are we gonna do when they're coming from you? So for you, so this is 78, no? Because they are corresponding angles. If they are corresponding angles, they are congruent. Now, these two angles are linear angles. So that means that this one is 180 minus 78, and that is 102. So F is just a 180 minus 102 minus 84. That is 30. Excellent. Oh my gosh, how do we find G? Okay, I have like I would like to draw a like a bird like an auxiliary line here through G. But I don't think that it's necessary. I don't think that we need it. Okay, so first of all, try to find all the alternate interior angles that you can. So for example, I know I believe that I need to draw my auxiliary line. I will draw it. And why do I want to draw it? Because I have two parallels and I have a vertex. So this is shouting. This is shouting. Draw an auxiliary line. Okay, so now maybe my C's are more useful. Yeah, because if this is 94, then this measures 180 minus 94, and that is 86. So now if I draw my C, this one is 86. And now I can draw another C. And look, these ones are vertically opposite. So I know that this one is also 86. Do you see it? because this is 86. So this is 86 because this is 86. So the jigsaw goes like this. This is 86. The vertically opposite is 86. And then this is 86. Okay. Then we can find this measurement because this measurement is just 180. Maybe I didn't need to draw my auxiliary line. Minus 86 minus 57. So 180 minus 86, that is 94. 94 minus 57. 94 minus 57, that is 94 minus 57, that is 41. So this one is 41. So this one is 41. So this one is, we can get it now because we can do 180 minus 86 minus 41, and that is 53. So we know that G is 53 minus 86. No, 53 plus 86. So that is G is 53 plus 86, and that is 139. Wow. I love it. I love it. Okay. This one is also shouting to draw an auxiliary line. So, but my auxiliary line, it won't go outside. It would go inside. Because look, now I have some beautiful triangles, no? I have, for example, now I have this beautiful triangle, and I have this beautiful triangle. And for example, from here, I can get the measurement of this angle. The measurement of this angle is 180 minus 72 minus 30. And 180 minus 72 minus 30, that is 78. And because this and this are linear, I can get this angle, no? And that angle is 72 plus 30. That is 102. In these problems, we love the 102. I believe that I have been saying 102, 102, 102. And now we can find the measurement of this angle, no? The measurement of this angle is 180 minus 102 minus 25. And that is 53. So H is a supplementary to 53. That is 180 minus 53, and that is also, it is an external angle. I could have added 102 and 25, 127. Wow. Oh, this is so beautiful. I would like to have you to ask you if it is clear. Could you rewind, or if not, send me an email if it is not clear? This problem is magnificent. Number 9 is magnificent because you need to draw an auxiliary line through where? Now, you want that your auxiliary line creates a triangle, as it did here. This line help you creating triangles. So I'm also going to create a triangle by doing this. Okay, kind of okay. No, don't like it. Don't like it. Okay, so what do we do? Okay, I'm also going to extend my lines. Going to extend my parallels. Okay, now I see it. Now I can see it. So, for example, if you observe, this 125 goes in here. because they are corresponding. And this, I am sorry, this, I also need to extend this line. Okay, I'm gonna repeat it. I'm gonna repeat it in a second. 115. I'm gonna repeat it. I'm gonna say it again in a second. 115. Because they are corresponding. So this angle, I'm sorry, kids. I'm gonna start all over again. Chicken commits mistakes. Sunday. Well, let me try again. So I'm gonna do this. I am going to extend my lines. I am going to extend this line. I am going to extend this line, and I am going to extend this line. Okay? So the triangle that it's useful is this triangle. And now, for example, we can look at this angle that is corresponding to this angle. So here you have a 1, 2, 5. And if you look at this angle, you can find it in here, 1, 1, 5. So now we can find the other angles. For example, this angle is 180 minus 125. And 180 minus 125, that is 55. And for example, you can also find the measurement of this angle. No, that is 180 minus 115. And so this is 65. Observe that this is also 65. So you can find I. Maybe you didn't need to extend this angle. But it's okay. No, everything's okay. It didn't damage you. So I is just 180 minus 55 minus 65. And that is cool. It is hard, don't you think? Like, it's okay to struggle sometimes, because by struggling, you will find the answer. If everything was nice and easy, then why are we doing this? Super cool. Okay, now this one is interesting because it has like like variables, no? So how do you do this one? Remember that this one is an exterior angle, so you can do that this plus this equals to this. So 10x minus 20 is the same as 5x minus 3 plus 4x minus 2. So 10x minus 20 equals to 9x minus 5. I'm going to subtract the 9x, so x, and I'm going to add the 20 equals to 15. Okay, but I am asking for angle J. So you need to do, okay, find this one. So do 10 times 15 minus 20. That is 150 minus 20. That is 130. So this measures 130. So this measures 50. So J measures 50, no? Because if you do 180 minus 130, that is 50. So that is 50. Nice. Okay. Okay. So everybody, take a deep breath. We're going to solve this, okay? Let us follow the same strategy as we did in this problem. Es más, this is the same problem. This is repeated. Sorry. This slide is repeated. Sorry. Oops. Okay. Oh, so those were all the problems about angles inside of a triangle. Now, the final problem is angles inside of a polygon. So a polygon is a shape that has many many sides. Poly means many, gon means side. Uh, so for example, here look at the triangles that you can find inside of a polygon. Um, my way of thinking this is the following. So we want to develop a formula for the angles inside of a polygon. So my way of doing this, so okay, you know that inside of a triangle is 180. Now, inside of a quadrilateral, you can think of it like you have two triangles, and these two triangles is 180 plus 180, so you will have 360. If you think of a pentagon, then you have three triangles, no? So that is 180, 180, 180. So that is 180 times 3. That is 540. Okay, if you have an hexagon, 6 sides, how can you divide it? Okay, maybe you can divide it like, okay, here you have now you have a 1, 2, 3, 4, 5. Now you have this is a 180, no? And now this shape that you have is a pentagon. And you already know that in pentagons, they add up to 540. So this is a 540 plus 180. Here you have an heptagon. So for example, if I do this, I know that this is 180. And what shape do I have here? What is this shape? 1, 2, 3, 4, 5, 6. That is an hexagon. And I know that in hexagons, I have 7 and 20 degrees. So that is 180 plus 7 and 20. That is 1,000. That is 720 plus 180. 900. That is not 900. Excellent. So there is like a general formula for this. My favorite way of explaining this formula is the following. So I'm going to erase this, and I want to explain it like how I like to explain it now. So you can think of a quadrilateral cut by 4 triangles. So each triangle is 180, 180, 180, 180. But you're repeating the angles around this point. So the angles inside of a triangle, of a quadrilateral, it's going to be 180 times 4 minus 360. No, because this is because the circle is a 360. In a pentagon, you can also divide it like that. You can think of a central point inside of my pentagon. Around this point, you have 360, and in each triangle, you have 180. So how many angles do you have inside? If you subtract the 360, well, then you will have 180 plus times 5 minus 360. In an hexagon, it is the same thing. You can divide it into triangles, and the angles around this point are 360, and the angles inside of each triangle is 180. So how many angles do you have inside of an hexagon? 180 times 6 minus 360. And so on and so forth. So I believe that you can determine, so now you can complete this table and discover it by your own. But the formula, general formula and how I like to write it, for me, it's 180 times the number of sides minus 360. And that is the angles inside a polygon. Polygon of n sides. An enagon. Okay, you can complete it. And now the cool thing about so that is the interior angles the inside angles, no, the interior angles. But what happens with the exterior angles? So an exterior angle, if you have a polygon, let me draw any polygon. No, horrible. A convex polygon. Let me draw a convex polygon. So my exterior angles, if you extend each side, this ones, but extend them in the same direction. So for example, if I decided to do this, then my exterior angles are all in the same direction. Like they are opening in the same direction. I hope that that makes sense. Or for example, another decision that I could have done could be drawing my exterior angles in the other direction. No. Drawing my exterior angles like this. So instead of going into that side, I can go into the other direction, counterclockwise. But all in the same direction. So these are my exterior angles. And now what happens with the sum of my exterior angles? All of the exterior angles, if I collapse my polygon into one point, I can see that the sum of exterior angles is always 360. So the sum of interior angles has a formula, and the sum of exterior angles is 360. I'm going to put that here, that important information here. So okay, so the formulas that you need to know. The sum of interior angles, you have two formulas. Well, one, I'm going to write n sides. It could be n times the measurement of one interior angle. It could also be a 180 times n minus 360. And the sum of exterior angles is always 360. Okay, with that information, now we can solve this problem. So to find the sum of the interior angles of a 31-sided polygon, that is easy. That is just 31 times 180 minus 360. Do that math. I don't want to do it. And the sum of exterior angles, that is 360. The measure of each exterior angle of a polygon is 30 degrees. So how do I find the number of sides of the polygon? Well, for this one, so this is an easy problem, no? The first one. The second one, you need to use this information. So you know, so we don't know the number of sides, but we know that the number of sides times 30, that is the sum of interior angles. And that is equal to 180 times n minus 360. No, this is the sum of interior angles. And now you solve this equation. So you have 30n equals to 180n minus 360. So I don't know, you can subtract the 180 and that will give you minus 150n equals to minus 360 and 360 divided by 150. Did I do something wrong? I committed a mistake. Sorry. Sorry, human. So the exterior angle measures 30. So my interior angle measures 150. Sorry. So the interior angle is 150. That means my equation was correct. So it is 150 times n, because this is the amount of sides times the measurement of each interior angle, that is equal to 180 n minus 360. Okay, now that makes sense. Now I subtract 180 n, that will give you minus 30 n equal to minus 360. So n is equal to 360 divided by 30. It will be positive 12. So it is a duodecagon. Now, maybe that is also a nice formula to add here, no? So exterior angle plus interior angle is 180, no? So if you want to move, if they are giving you the exterior angle, you can get the interior angle by, because they are supplementary. Okay, so find the measurement of each exterior angle. So if they are giving you that the interior angle is 165, then you know that the exterior angle is just 180 minus 165, and that is 15. Now that you know the interior angle, you can set the same equation as we did here, no? You know that 165 times n is the same as 180 n minus 360. So you subtract 180, and 180 minus 165, or 165 minus 180, that is minus 15n, equals to negative 360. So n is equal to 360 divided by 15. And then it's 24 sides. Okay, now this one, they are giving you the sum of measures of the interior angles. So you know that that 180 times n minus 360, that is the sum of interior angles, equals to 1980. And you solve, no? So 180 n equals to 1980 plus 360, and that is 2340 divided by 180, that is 13. And that is cool. Tridecagon, 13 sides. Okay, the last two. So to find the measurement of angle A, that is the internal angle of a pentagon. So to find the internal angle of a regular pentagon, well, you know that in a pentagon, so you have 5 sides. So in a pentagon, you have the sum of interior angles is 180 times 5 minus 360. And we said that 180 times 5, that is 540. And because all the angles are the same, so each angle measures 1/8. 108. So for example, that is A, 108. B is the supplementary of 108. So that is 72. And now, because this measures 72, and this measures 72, because if you have the two angles that are, because both angles are supplementary to 108. So what type of triangle is this triangle? It is an isosceles triangle. Well, D because it's an exterior angle, this is immediately 144. And C is a supplementary to 144, and 180 minus 144, 36. So C is 36. Nice and easy. Okay, so now here again we have a pentagon. That means that this is 108. So E is 72. Nice and easy. And here we have a 1, 2, 3, 4, 5, 6, 7, 8. We have an octagon. So 180 times 8 minus 360. 180 times 8 minus 360. That is 1080. And that divided by 8 is 135. So each of these angles is 135. So F is a supplementary to 185, to 135. So F is 45. 72. Okay, and here we have 108, and here we have 135. So we have that G is G is 360 minus 108 minus 135 because of this circle. So G is 117. F is 45. And we can calculate H because inside of a quadrilateral, inside of this quadrilateral, angles add up to 360. So to get H, we just do 360 minus E minus F minus H. So we do 360 minus 72 minus 45 minus 117. 126. Why 360? Because that is 180 times 4 minus 360. No, that is the angles inside of a quadrilateral. And you subtracted the other 4. Okay, kids, I hope that you enjoyed this class. If you have any question, please let me know.